Like it's time, my clock is running. Hello and welcome. It's great to see such a big crowd here right after lunch. That JavaScript thing must really be catching on if I can bring out a crowd like this at the Microsoft conference right after lunch on the fourth day of the conference. Oh, is it third day, I suppose. This is Dev 307, JavaScript the language. We will be talking about JavaScript as a language, less so as a part of the web developer platform more broadly. My name is Andrew Mijatovic. I'm a program manager at Microsoft. I work in the developer division as part of the browser programmability and tools team. It's a mouthful, but the bottom line is my team created Chakra, the JavaScript engine in IE9 and IE10, as well as the foundational layer behind the Windows 8 HTML and JavaScript applications. We also build the tools in Visual Studio for JavaScript, as well as the tools in the browser for JavaScript. And in fact, here's a place for my shameless plug. I'll have another session tomorrow at the same time, the last slot of the conference, only for those who are tough and can last that long. That will cover Visual Studio tools in Visual Studio 2012, specifically for JavaScript, the things that we've improved. But today, we're focusing on JavaScript and JavaScript as a language only. But before we dive in, I know that the audiences tend to be diverse in those types of talks. I'd like to get a show of hands to a couple of questions. How many of you guys are seasoned JavaScript developers? You write JavaScript most of the time, and you've been doing this for a few years now. OK? There are a few folks, but generally a minority. How many of you have recently converted to JavaScript from some other language? So now you do a lot of JavaScript programming, but most of your previous career was in other languages. I belong in that group. Anybody else? Excellent. A few hands. How many are just curious about JavaScript, even though most of your time in your professional life is in a very different language? OK, great. So we have a majority of folks in that group. Excellent. I think there will be enough in this talk for everybody. And I'll try to tailor the content a little bit what I can. I personally am a recent convert to JavaScript. I've spent most of my life programming C++, then Java, then C#. And I've been resisting quite effectively JavaScript for a number of years until I got sucked in about 2 years ago. And the reason I've been resisting it because I didn't really think of JavaScript as a full-blown, full-fledged language. To me, it was always kind of a toy scripting thing in the same sense that maybe the command shell has a language. But I've been set straight. And in fact, I now know that it's a misconception. JavaScript is a full-blown language that has a well-designed and very small and consistent core around a few foundational concepts. And the point of this talk is to dive into those concepts, to shed some light on them so you can have a better understanding of how your code runs on the JavaScript runtime, how the libraries are put together, how the DOM works internally, and so forth. So we'll focus on those foundational concepts. But before we dive into that, let's talk a little bit about the historical context of JavaScript. JavaScript was created around 1995. And maybe in about 1996 or so, a year or so later, it started popping up in a number of websites of the time. When I went back to try to find some of the content from that period, it actually turned out to be fairly difficult. Web is moving pretty fast, and there's little content left from 15 years ago. But I found this one example, and I think it actually is quite representative of the state-of-the-art JavaScript usage in 1996. Wouldn't it be cool if your website could pop an alert in response to a button click, right? Today, that sounds pretty funny. But the truth is, JavaScript, when it was first envisioned, it was designed to serve purposes like that. Just very simple scripting for adding a little bit of interactivity into otherwise static websites. Now, in that context, it's quite remarkable that very quickly, in just a matter of a couple of years, the language that was designed to do the simple scripting was used to do fairly complicated things. So what you see there is the Outlook web application, or web access, which Microsoft released in 1997. And it was already a fairly complicated application that had much of the UI that looked and felt a lot like the rich client experience. And to this day, the Outlook web access is an ever more complicated and bigger application with ever more interactivity. And just as another non-Microsoft example, if you look at Gmail, in 2010, that code base was about 500,000 lines of code, excluding comments. If you bring the comments in, it was almost 1 million. And that's from 2 years ago. And obviously, we're talking about a really large-scale application, large-scale engineering efforts to maintain a code base of that magnitude. And one of the key enabling factors of those ever bigger and ever more complicated applications being created in HTML and JavaScript have been the performance gains in JavaScript in the recent years. Traditionally, JavaScript has been considered a slow scripting language that was not on par with competing client technologies, be it C++, C#, Java, what have you. But in the last 5 years or so, this has dramatically changed. So the curve that you see there is quite steep. You can see how in the last 5 years we've made very big improvements. What's even more remarkable is that that curve is actually plotted on a logarithmic scale. So we're really talking about a 100-fold improvement in performance over a period of just about 5 years. Now, those numbers come from the WebKit SunSpider benchmark measured on IE. And they don't necessarily represent the entire span of JavaScript performance, but that's just a good example. And I could spend the entire day talking about it because I'm actually responsible for JavaScript performance in Chakra, but I won't dive into what's going on in the compiler and the runtime and such things to make it happen. Today, we're here to talk about the language. But if you're interested, I'd love to hear your questions and answer your questions in that aspect as well. So those performance advances really enable more and more applications being built and reliably expect high performance from all of the modern browsers. The other aspect of the language is the standard behind it. JavaScript was first standardized under the official name of ECMAScript 1 shortly after it was introduced in 1991. And then over the next couple of years, ECMAScript 2 and 3 were added with some added features to the language like regular expressions, exceptions, and so forth. And then over the next several years, a bigger effort was spun off to add more, to move the language forward in a little more dramatic way, I suppose, by adding features that were familiar from other languages, like Java or C#, adding classes or static types and so forth. But that effort sort of ballooned quickly and became too large and somewhat disconnected from where the web was going at the time. And so ultimately, in the early 2000s, it was abandoned. In its place, ECMAScript 5 was started as an initiative to try to bring into the language more limited set of more fundamental capabilities on which higher abstractions could be built. And that effort succeeded in being standardized in 2009. And in fact, in all modern browsers, the JavaScript standard that is currently implemented is ECMAScript 5. Now, the standards body did not just sit down on their laurels and give up on advancing the standard. The TC39 committee, which is the standard body, is meeting roughly every two months or so, trying to bring in some of those concepts that were originally abandoned in ECMAScript 4, but they were actually essentially good if brought in sort of in a more incremental fashion, such that adoption could be a little faster than ECMAScript 4 would have been. So that work is ongoing, and it's targeting sometime in 2013 as probably ECMAScript 6. We'll see. Only the future will tell exactly where we land, but that's roughly the idea. And throughout this talk, you'll see I'll be highlighting some of the aspects that were new in ECMAScript 5 with this little greenish kind of a box. What's interesting about ECMAScript 5 for this talk is that it allows us to look a little under the hood programmatically, and I'll emphasize those concepts that are new. And it's likely that you're not using those very much today, or you may not even be familiar with them, so I'll try to explain what they are and what they do. And by the way, we have about an hour worth of content. I'll ask you to hold off on questions until the very end. I'll try to leave some time for questions. And if we run out of time, there'll be my email, so you can feel free to shoot me a mail at a later time as well. Great. So like I mentioned before, the main goal of this talk is to give you some insight into the foundational layer of the language. How is the language itself constructed, and how does this really influence the way your programs or your libraries or the DOM or what have you actually run? The hope is that this will give you more insight and it will enable you to think about things a little more clearly. So we will talk about some of the core concepts of JavaScript, the objects, the prototype, the functions, some of the common patterns that are used. And I'll talk about what's new in ECMAScript 5. But I will not talk about, this is not meant to be a general introduction to web programming, so I will not be covering HTML. I will not be talking about CSS. Those are outside of the scope. And this is also not intended to be a complete tutorial about JavaScript. A complete tutorial will take much more than an hour. And in fact, it wouldn't get to the heart of the things that I believe are actually interesting about the language. So again, this is going to be a peek under the hood of how things are really put together. JavaScript is really built around about 5 key themes. It has a C-style syntax, familiar from many other languages. It is a dynamically typed language, and I'll explain what that really means for JavaScript specifically. And then it is made up of those 3 basic concepts: objects, functions, and prototypes. And prototypes allow you to set up inheritance and sharing and such things. I will really focus on the last 3 here for the remainder of this talk, but I want to give you one slide of context on the first 2. So the C-style syntax. This is a very busy slide. But the point of it is that even though the C-style syntax that is familiar from other languages might seem like a pretty big, chunky thing, because that's actually a fair amount of syntax in C++ or in C#, for example, the JavaScript subset of it is actually fairly limited. In fact, all of it, just about, there are a couple things that are left out here, fits on this one slide. That's all of the syntax of JavaScript that really exists. There isn't much more than that. But the nice thing about it is that it is familiar. So that is one of the reasons JavaScript has been so successful, is that it's quite approachable for people who have experience in other C-style languages, of which there are very many. There are a couple of notable differences. So let's call them out here. JavaScript has very convenient and succinct object literal, function literal, and array literal syntax for creating those constructs easily. It has automatic semicolon insertion. So you can leave off semicolons between statements, and they'll be automatically inserted for you by the compiler. And most of the time, the code works exactly as if the semicolon was there. The fact that it's most of the time makes some people create tools that force you to inject those semicolons. But you'll actually see that, well, if you explore JavaScript libraries, you will notice that some of them very intentionally leave off those semicolons, sometimes to save a few bytes of network transfer. There are regular expressions built directly into the language. Notice it's not a string or it's not an object that encapsulates a string. It's just a regular expression right there in the language itself. And then there's the foreign enumeration over the properties of an object. It's one element of the introspective capabilities of the language, and it kind of hints at how deeply into the language that capability is baked. So that's about as much about the syntax. Then the dynamic typing. So JavaScript is a dynamically typed language. And what that really means, the way to think about it, is that at runtime, any given value has a type. I mean, at any given point, if I walk up to a variable and I check its value, it'll be a string, or it'll be a number, or it'll be a Boolean, or something. At any given point, it has to have a concrete value of a concrete type. But variables or parameters don't have types. So I don't get to say, this variable will only ever be a number and guarantee that it always will be a number throughout the execution of a program. It can be assigned something else at any given point. It could be a string at some point if I check. Similarly, for parameters, I don't get to say, this parameter will always only be allowed to be a Boolean. Someone can pass me a string just as well. So there are 5 fundamental types in JavaScript. There are numbers. There are Boolean values, strings, and then 2 types of undefined. There's the undefined itself and a null. What's kind of interesting here, different than most other languages, there are no different types for integer values and floating point values. There's only a number. Number represents both integers and floating point values. And then there are objects. And in fact, objects will be the focus of the rest of this presentation. And there are, in fact, 3 different flavors of objects. There are objects that you define, for instance, through object literals. Those are user-defined objects. There are host-provided objects, such as the DOM object model. So say the document or the window or what have you, that comes from the host. And then there are built-in objects. Those are provided by the runtime itself. They just, if you spin up JavaScript, those are available to you. Object, array are a good example of those. Now, the distinction between them is very subtle, and in fact, for most purposes, you don't have to worry about them. You can treat them the same way as if they were all identical. And in ECMAScript 5, they're becoming more and more identical, in fact. So much about dynamic typing. Let's now dive into the fundamental concepts of the language. So the first one is objects. In objects, unlike in other languages, where object-oriented languages, where you have to define a class first and then create instances of that class, there are no classes in JavaScript. Objects are just bags of properties. So in this case, the O1, I'm creating using a blank object literal. It starts off without any properties. And I can then define properties on this object by using simple assignment. So the first assignment here will create a property x on this object. The second assignment will change the value of it to 4. Right? So no classes involved. I can add, remove properties at will at any point. I can use an object literal with some pre-populated values in there to pre-create those properties on my object. As in this case, in object 2, I see x:3. And the last point there is that functions can be used as values of properties. So the second property of O3 is, in fact, a function. The value of that property is a function. And the first one, its value is another object. So property values can be of any type in the type system of the language. And one thing that many developers are not actually aware of is that the familiar dot notation that is used for in many other languages for accessing properties on the objects is just a shorthand for the index notation. So the two first lines at the bottom, o2.x and o2 of x, are identical when it comes to the runtime execution. And in fact, because objects are just bags of properties that are keyed off of arbitrary strings, I can use strings that have spaces or some other characters that would not be allowed as identifiers as property names. But if I do, then I have to use the index notation. I cannot use the dotted notation for that purpose. So that's the last example over there. We covered those. Excellent. The next fundamental aspect of objects is that they have prototypes. So I already mentioned there are no classes in JavaScript. The way you achieve inheritance is through prototypes. We'll delve into this in the next couple of slides. But let's start here. So I have a blank object O1. And yet I can walk up to this object and call value of on it. And it'll return a string that's object string. So how can it be? That object does not have a value of method on it. So where does it come from? Turns out it comes from a prototype. So the moment I created an object, this object inherits from the default prototype called object.prototype. And that object.prototype defines a few useful functions, among them toString and value of. And so the value of is now available on my O1. And the way this works is, at runtime, the JavaScript engine behind the scenes will walk up to the object and check, do you have value of property? If you do, I'll grab that one. If you don't, I'll check your prototype and see if it has value of. If it does, then I'll grab that one. If it doesn't, then I'll keep walking up the prototype chain, however far it leads, until I find one. And if I find one, that's the one I'm going to call. Traditionally, in JavaScript, as of a few years ago, this was a very slow process. But in recent modern JavaScript engines, this is actually quite fast. Another interesting thing here is that to do overriding in JavaScript, all I have to do is define that property on my object. So notice O2 in this case defines a value of function that returns 10 all the time, and that shadows the one that would have come from object.prototype. So overriding is as easy as providing the value on the given object. Now we're getting a little deeper into inheritance. Again, no classes. Objects inherit directly from other objects. So here, in this case, when I create point2d and give it some properties x and y, this one inherits from object.prototype directly, kind of like we saw in the previous slide. Then with ECMAScript 5 comes an object.create method that allows me to create a new object from an arbitrary prototype. So here I'm creating point3d, inheriting from point2d, and I'm giving it another property z. So now what you see here is point3d has its own property z, but inherits property x and y from point2d, and it also inherits value of and toString from object.prototype. What's interesting here is if I change the value of x or y on point2d, it would also be changed for point3d, right? It's point3d doesn't have a separate copy of those properties. It actually points back to the prototype's copy of those. And now if I created another object that inherited from point 2D, call it location, and say give it a name, the point 3D and location inherit from the same point 2D object. And since they do, they share whatever state and whatever functionality is available in point 2D and up the prototype chain hierarchy. So prototypes are both a mechanism for inheritance as well as sharing in JavaScript. Right? So a very fundamental concept. Again, no classes, just prototypes. Now, traditionally, until ECMAScript 5, objects had only data properties. So most of the properties that you saw in there just had a value, right? And they're called data properties now. In ECMAScript 5, another type of property was introduced called accessor property. That's a common pattern that you see in C# through property getters and setters, and in JavaScript, in Java, I think as well. It basically allows you to inject custom code that will be executed anytime a value is set or retrieved from that property. Very useful mechanism for all kinds of interception, for logging, for providing validation, for providing computed properties, all kinds of things. But it also gives you a little hint that there's more to properties than just the value. And in fact, great, we covered that. Behind the scenes, anytime I add a property to an object, in the JavaScript runtime, there is this metadata associated with that object. It's called the property descriptor. And it contains a number of attributes that determine the behavior of that property. So for example, for a data property, I have a value, which holds the actual value of the property, and then a number of attributes. Whether it's writable, whether I can change the value of that property, whether it's enumerable, so if I do for in, will I be able to see that property? Is it considered part of the state of the object? And configurable is a little trickier. It basically determines whether or not I can change the properties of that property, so the attributes of the descriptor. For example, in this case, the data descriptor is configurable, so I could change it to be non-writable, or to be writable, I guess. I can change the writable attribute of it. Right? So configurable relates to this metadata about the property. And for the accessor property, I do not have the value or the writable, but instead I have the getter and the setter functions. And in fact, that pair determines whether my property is writable, right? Because I can provide a blank setter, and in this case, the property is effectively non-writable, right? Because its value will never change. And then enumerable and configurable remain. And until ECMAScript 5, even though this metadata was available in the runtime, it was not accessible to me as a developer to see what's in there. But in ECMAScript 5, great, we covered all these in detail. Now there are APIs that allow me to look under the hood and see some of those property descriptors. So I can use object.getOwnPropertyDescriptor to see the descriptor of a given property on a given object. I can define a new property or modify it, and I can provide explicitly that descriptor so I can control all these attributes. And then I can also walk up and find out what the property names are on the given object without walking up the prototype chain. And I can also find out what the prototype of the object is by calling getPrototypeOf. And just in a moment here, in a demo, I'll kind of walk you through what this allows me to do. So I'll pull up a chair, and let's see if we can do this. OK. So what I have here is, this is IE10, but most of the demos would work just fine in IE9 as well. And this is just the Bing website, the American version of it. I wasn't aware, but the local version is slightly different. And then I opened up here the F12 developer tools that come with the browser. And I have the JavaScript console open. So I can type in any valid JavaScript code in here. Oops, that's not exactly valid. And I can see the result of it, right? That's quite primitive. But let's see what we can do about the objects and properties and property descriptors. So let's start off by defining a very simple object O. And I'll use the object literal. And I'll give it a property hello with a value of 5, right? And if I execute this, there's my object with that property. But if I want to peek behind the scenes, let me look at the property descriptor here. So let's do object.getOwnProperty. By the way, I'm hoping everyone in the back can see, but if not, I can zoom in a little bit. Can you guys see the text? I see nods. OK, great, perfect. Property descriptor of object O and property hello. And, aha. Hold on, what do I do here? Did I misspell it? Of course I did. There we go. So there's a descriptor, and as you can expect, the value is 5. And by default, all the other attributes are true. So I can change the value of it. I could reconfigure it. And also, it'll appear if I do for in. So great, that's my own object. Let's try one of the built-in objects. So date is one of those built-ins that comes from the JavaScript runtime. And it has a method now on it. So let's try the same thing. And you'll notice here the value of this property is actually a function. So again, this speaks to the fact that functions can be assigned to properties as their values. And this one's also writable and configurable, but it's not enumerable. So if I do for in, this particular method will be hidden. That's just what the designers of ECMAScript decided, that property is not considered part of the state of the object. Now, let's make it even more interesting, and let's walk up to the HTML elements. So we're going to look into the DOM a little bit. We'll look into its prototype. And we'll take the inner HTML, because that's one that's very commonly used. And now, if you look at that, you'll see that actually this is an accessor property, which has a getter and a setter. And the fact that it says native code implies that those are implemented in the DOM, not in JavaScript. And that's, in fact, whenever I set the inner HTML, some code will be executed that will populate that element in the DOM. Now, what's interesting is that this property descriptor says that this property is actually configurable. So that suggests that I can walk up to it and change it. So let's do that. First, let me save off this old descriptor here. Great. And then we're going to create a new one. And the descriptor is just an object, so I can create it with an object literal notation. And I'll leave anything that I don't want to change. I will just omit it entirely, but I'll give it a new setter property. So my setter is going to be a function that will take one parameter. And the first thing it'll do, it'll spit out on the console whatever HTML content was passed to it. So we'll do console.log, and we'll say inner HTML was changed to, and we'll pass the HTML content there. And then the next thing I have to do, I have to defer back to the original setter, so the functionality remains the same, so it actually gets inserted into the DOM. So let me grab the old descriptor and take its setter method, which we saw up above, and I'll use the function.call, which we'll cover a little bit later when we talk about functions. I'll pass it the same this object that was given to me, and I'll pass it the HTML content. Great. So I have a new descriptor. Now I have to set this descriptor on that property again. So I'll use again, a piece of ECMAScript 5, object.define property. And I'll define it on the HTML elements.prototype. We're talking about inner HTML. And I'll give it the new descriptor right here. So the effect of that will be that whatever I didn't specify will remain unchanged, and what I did specify in the new descriptor will override whatever was there before. So let me hit enter. And now let's go over to the browser. And what you'll notice here, when I mouse around, those little boxes appear, and they show me a little tooltip to kind of entice me to navigate somewhere and do some interesting searches. I mistyped something. Oh, thank you. You know, I've run through this demo probably 50 times, and I mistyped it, I think, 25 of them. Thank you. That would not have worked if I didn't do it right. Let's try this again. All right. Let me clear this to make sure that it actually took. I believe it did. OK, good. We now might have an interesting chain of properties, but that should still work. OK, great. So let me navigate back and forth. And if we watch the console there, what's happening? We froze up a little. OK, I think that's probably because I created now a long chain of descriptors. Yeah, in fact, I ran out of stack space here. But you'll notice that let's try to do it again, this time cleanly. So I'll copy that. We will refresh the page here. And let's do it once, and let's do it correctly. All right. Now, if I'm lucky, excellent, great. So you'll see that all the changes to inner HTML that the website performed now went through my piece of code before they went into the DOM. And my piece of code then spits out all that text. And if I grab one of those, 40 years, there it is, and others appear there as well, right? So the accessor properties give me an interesting capability as a developer to plug in somewhere under the hood, even as far as DOM, and get my code executed. So very powerful functionality. This is just a neat little trick, but you can use it in other situations as well. Great. So that's this for the first demo. Let's switch back to the slides. OK, so let's summarize what we talked about with respect to objects. Objects, again, just bags of properties whose names are just strings and could be arbitrary strings, don't have to be identifier strings. You can add to them and remove from them. They're a very flexible data structure, don't require any classes. The only way that you get inheritance or sharing is through prototypes, and objects inherit directly from other objects. And then object properties, there's a little more to them that seems to be on the surface. They can have values, but they also have those more complex descriptors behind them. And you can now inspect them using ECMAScript 5 APIs. And you can make them into accessor properties with getter and setters. The next fundamental concept of JavaScript is functions. And this one is very important to internalize because functions are in some fundamental ways different than they are in other languages. So they are, in fact, first-class values in the language. What that means is, yes, I can think of functions much like I do in C++ or C# as just chunks of code that I create. But I can think of them as first-class values. So in this case here, I am creating a function literal, and then I'm assigning the value of it to this variable. In many ways, they look and act the same, but there's a fundamental difference there. I can pass functions around just like I pass any other value, a number or an object or whatever. In more statically typed traditional languages, there are ways to do similar things through function pointers or delegates and so forth. But functions themselves in those languages are not typically first-class objects. In JavaScript, they are. So I can do things like this. Here I'm creating a new variable, and I'm assigning it a value of that first function that I created, right? This is not something that I would be able to do in C++. If I made a function, there it is. If I made a method, it sticks to that one object, right? And an interesting thing that I can do with functions is pass them to other functions. In this case, the wrap function just calls the original function that was passed to it. That's not terribly interesting. But it turns out JavaScript libraries very commonly use this pattern to provide very interesting functionality. Some of it is to set up certain object-oriented patterns, for example. So this is a very powerful element of the language, that functions are indeed first-class values. They also happen to be objects. And as objects, they can have properties, which may seem a little weird, but functions do have properties. They're slightly different than objects in the sense that they, by default, inherit from function.prototype rather than from object.prototype. So they have a little richer functionality already baked into them. For example, you see that toString is overridden in function.prototype and gives you richer functionality than the same function from object.prototype. If you walked up to a function and called toString on it, you'll actually see the source code of that function spit out in a string form. And also, every function by default gets two instance properties, the length and a prototype. And the length is just the number of arguments that the function takes. And that should show up on the slide right now. So in the case of the sum, it takes 2 arguments, so its length is 2. And the prototype, we will cover it at length in a moment. But you can see here that if I call the get prototype of on the sum, it'll return function.prototype. So perhaps the most confusing aspect of JavaScript is the handling of the this pointer or the this implicit argument. The confusing part about it is that it's actually bound dynamically. And what does that mean? So every function implicitly gets a this parameter passed to it. There is no different concept of a method. There's just a function, and every function gets that parameter. Many functions don't ever make use of it in any way. Like in this example, my sum just returns a sum of two numbers that were passed to it. But because it's assigned to a property of the object, I can call it as if it were a method of this object, right? I can use the dot notation, and then the object will be passed as this parameter to this function. Again, for this function, it doesn't matter very much because it doesn't try to access any of the properties of the object. But here's another one. Here, the object 2 actually has a piece of state. It's the offset. And the function that is assigned to property sum tries to access that property in order to compute the sum. And if I call that function on the object 2 as a receiver, that object will be passed as this parameter, and everything works. I get 14 as I expect. But because functions are values, they're not tied to that property. So I can extract the value of the object2.sum and assign it to some local variable, right? That variable is not bound to any object. And if I call that function directly, passing 3 and 4, what I get back is not a number. And that's surprising. But the reason this works in this way is actually quite consistent and cohesive. What is happening here, when I call a function without passing any receiver object, like without doing obj.something, this pointer being passed to the function is the global object. In strict mode, it's actually undefined. But in traditional JavaScript, it's a global object. And global object, in this case, does not have property offset defined on it. So when this function comes and tries to extract it from the global object, it gets undefined, and undefined plus 2 numbers is not a number. So the key concept here is that this parameter is bound dynamically at runtime. Depending on how I call the function, it will get the object passed into it, or will get the global object passed into it. In traditional languages, that binding happens statically. When I define a method on an object, that this pointer that we pass to it will always be one of those objects. Here, it's bound dynamically. So like I said, it's perhaps the most confusing aspect of JavaScript. But once you internalize this important fact about it, that it's dynamically bound, it becomes a little more clear. It turns out that it's actually a very powerful concept, too. I can have a function that expects a certain object, and it'll try to extract some values out of it. I can explicitly call that function on some arbitrary object, which I happen to know has to those properties that the function relies on. So in this case, I could call f passing object 2. The first parameter will be then passed as this pointer. And then I can pass the additional arguments as the remaining arguments to the call function. There are two varieties of it. There's the call and there's the apply. The difference is subtle. The apply takes an array of values and passes this as arguments. Turns out that's convenient in many circumstances. And those two, call and apply, are used very extensively throughout many JavaScript libraries, in many cases to give you the more class-based object-oriented programming illusion in JavaScript. So again, very fundamental concept, very important to understand how this works with functions. Building on that concept of the this pointer, there is a new operator in JavaScript. Again, the new operator was added in order to give you a more class-like programming experience. So in this case, I have a function person. All it does is just takes two arguments and creates them as properties on whatever the this pointer is that is passed to it. And then I can create instances of objects of class person. I can think in many ways about that person as a class. There are some nuances there, but that's a reasonable way of thinking about him. I'm creating a Bob and an Anil by just calling new person and passing some arguments. And as I would expect, Bob will have a first name equal to Bob. And in fact, if I gave that prototype some functionality, like get full name, which would be computing the full name by concatenating the first and the last, I can call that function on Bob. The interesting thing is that new is not an intrinsic concept in JavaScript. It actually performs a sequence of steps that you can do yourself, and that we will do in a moment in a demo. The first thing that it does, it creates a brand new object. You could use an object literal to create a blank object. But then it sets its prototype to whatever the person.prototype is. And then finally, that object is passed to person, the function, as the this pointer, so the function can initialize it. And behind the scenes, if we try to put it all together, we get a hierarchy of inheritance of prototypes and linking of prototypes to constructors. One thing I did not mention in the previous slide is that this person function in this case is often referred to as a constructor function. And by convention, it is capitalized. It's just a convention. There's nothing in the language that says that it has to be capitalized. But conventionally, that's how it's done. OK, so the simple act of creating an instance of Bob from the person function or person constructor sets up a pretty rich hierarchy of objects in the runtime. And let's start looking at it here. So Bob has a first name and a last name, and then it has an implicit property prototype pointing to person.prototype. And that person.prototype happens to have the getFullName method. We've seen that before. There's nothing new here. Great. I can call getFullName, and I can access the local properties. Bob and Anil, the two instances that I created before, share the same copy of the getFullName method, right? Because it's defined on the prototype, they share the same prototype. OK, but where's person in this picture? I see person.prototype, but that's not the same as the person. So here's the bigger picture. The person is the constructor function that has a prototype, which is person.prototype. And the person.prototype points back to its constructor by a constructor property. So we have this bidirectional relationship here. And this is useful in checking the class, if you will, conceptually, checking the class of an instance. So if I walk up to Bob and see if it's an instance of person, I'll get true. And the way this is really done, again, it's not a fundamental concept. The runtime walks up the prototype chain and says, OK, you're a Bob. What's your prototype? There's the prototype. Does that prototype point to a constructor that is person? If so, then yes, you're an instance of person. If not, I'll walk up the prototype chain up and up and up until I find one that has a constructor equal to person, or until I run out of prototypes. So again, note the core concepts are not expanded here. It's all just prototypes and functions and objects. This allows me to also do sort of contrived programming. I can walk up to any arbitrary instance. I can find out what its constructor was. And then I can use that constructor to create a new instance of the same conceptually class. So this last line here would check Bob's constructor and create kind of a clone of Bob with different first name and last name. It's possible, not very commonly done. But there's even more to this than what you see here. So person.prototype is just an object. Objects inherit from object.prototype. In fact, object.prototype is kind of the root of the object hierarchy in JavaScript. Person, the constructor function, is a function. And as we talked about it before, functions inherit from function.prototype, right? But function.prototype inherits from object.prototype. I know it gets a little messy and complicated, but that's how it works. Again, three fundamental concepts all linked together. The interesting thing here is that both Bob and the person, the function, all ultimately share the same value of that comes from object.prototype. If you trace through all these arrows, you can see that at the end of the rainbow, there is the value of function. But where's the object? We have object.prototype, but we don't have the object yet. That's the full picture. So object is a constructor function for the object.prototype, from which all the other objects in JavaScript inherit. Function is a constructor function for function.prototype. So the full picture gets pretty big. The simple act of creating an instance of person, in this case, builds up this entire graph of things inside the JavaScript runtime. But again, I want to emphasize it over and over again. The main fundamental concepts are only three here. There's only object, there's only function, and there's only prototype. There is no class. There is no instance of. All these other things are derived from those three concepts. OK, so in the next demo, I'll actually show you how this works. We'll reconstruct a new operator by hand. And then we will see how HTML elements inherit up the prototype chain. So we're going to use the same set of tools. I'll refresh so we get rid of our old descriptor that we created. And the first thing we're going to do, we will just create a very simple constructor function called point. So function point that'll take two parameters, x and y, and assigns them to properties of whatever object is passed to it. Great. So far, nothing revolutionary. I'll create point A the traditional way, and I'll pass it 3 and 4, right? So I'm using the new operator here to create an A. And if I want to see the value of A right now, there it is. It has 3 and 4 as properties, x and y. Let's add a little function to the prototype of the point. So we'll do point.prototype. And let's call it getDistance. And all it'll do, it'll compute the distance of that point, Cartesian distance from the origin. So we'll do return math.square root this.x times this.x plus this.y times this.y. Great. And let's look at A again. I missed something. I do it all the time again. This would be a legitimate syntax in other languages. Here I actually have to say I'm assigning a value that is a function here, right? So I'm creating a function instance and then assigning it to the getDistance property. Again, this is this nuanced thing about functions being first-class objects in JavaScript. So now if I look it up, I see that getDistance is also available to me. And in fact, I can call getDistance, and I'll get 5. So far, so good, but this is just traditional JavaScript. Now let's try to deconstruct that new operator and do it all by hand. So let's create a function that will do the same thing as the new operator. So let's call it function build. And it'll take that constructor function. I'll call it seater for constructor. And it'll take arguments that will be passed to this constructor. And as I was describing the new operator, the first thing that it does is create an instance, a blank instance of an object, which inherits from the prototype of that constructor. So with ECMAScript 5, I can do object.create. And I can pass the constructor.prototype. And then I'll assign it to a local variable. Not 0. Oh. Great. So now I have a blank object that inherits from the constructor's prototype. Then I'll have to call that constructor. And I'll use the apply variety because I'll pass the arguments as an array. And I'll apply it to the object that I newly created. So this object will be passed in as the this parameter to this function. And then I'll pass the arguments to it as well. And then last but not least, I will return this object. And if I did it right, then I should be able to use that build function to create my object. So let me resize this a little bit. In fact, I can make it altogether bigger. There we go. Oh, where's my cursor? Well, seem to have lost my cursor. Let's see what happens. Let's just cut it all out and start over. Hold on. Hit F12. There we go. I'm back. OK, so now let's create a point B. But instead of using new point, I'll just use the build function that I have. So build, and we'll pass it the point, the constructor function, and the two arguments in the form of an array. And let's see what B looks like. Looks very similar, right? It has the same x and y, and it has the getDistance method, very much like A. And in fact, I can call the getDistance on it. And I should be able to get 5. So nothing special about new. I can do it by hand if I want to. Not that I recommend doing it, because JavaScript runtimes can optimize the new operator very heavily, and they do. So creating objects via the new operator is quite fast. Doing this the manual way would be pretty slow. But it shows you that, again, the fundamental concepts are very few in JavaScript, a very small core. But then other things can be built on top of them. Great. The other interesting thing is to look at the DOM a little bit. So in the not Visual Studio, but browser tools, we have an HTML tab that allows me to see exactly the DOM structure of the page that I'm looking at. So here we have a head and a body, and in the body I have this table. And I'll grab the ID of this table. And I can programmatically access that DOM. So here I will save off that table, and we will do document.getElementBy.id. Pass in this ID. And lo and behold, that table is here and has some properties. In fact, if I click on the Add to Watch window, there we go. I'll make it a little bigger. You can see that this object has a whole bunch of properties. In fact, something like 300. Only 250 of them are shown, right? So let's say I'm curious about where these properties all come from, and I can programmatically inspect this now with ECMAScript 5. So let's do console.log. So we'll log that to the console, and we will look at object.getOwnPropertyNames. Let's see what all the property names are on this object, and pass the table as the object in question. And then, well, it showed me nothing. Well, it may be clear if I do it this way. So it turns out that the table itself has no properties. So all these 300 or so properties must be coming from the prototype. So let's do a little prototype chain walk and see, first of all, what table inherits from, and then also where all these properties come from. So let me do this. Let's get a prototype variable, and let's get the prototype of that table. .get prototype of. Again, this is an ECMAScript 5 concept table. And then, now I'm going to use console.log. And let's look at the constructor property of the prototype. And let's also display the properties. Own property names of the prototype. And if it wasn't clear, the own word in those APIs indicates look only at the instance. Don't walk the prototype chain when you're extracting property names. This allows me to look at individual objects one at a time. So let's try this. It turns out the prototype or the constructor function of the table element is something called HTML table element. And it does indeed have some number of properties. But it doesn't quite look like the full 300. So we'll keep walking. And here I'm going to start cutting and pasting to save you some pain of watching me type a bunch. So now what I'm doing is I'm getting the prototype of the prototype. So I'm walking up the chain. So up above is the HTML element constructor function. And I do get some additional properties there. And let's keep on going down the rabbit hole. Now there's an element that sits above it. And now let's go up higher. Oops. Now there's a node, and we're getting to the bottom of it. Next one up is, can anybody guess? Object. So at the bottom of it all is the object.prototype. Everything inherits from object.prototype, even the DOM nodes and DOM elements. The constructor function of the object.prototype is the object function, right? So everything bottoms out at the object. And the interesting thing about it is the object is actually the constructor function. Object.prototype is the thing that everybody inherits from, even the DOM. So really, particularly in the modern browsers, more and more of the DOM is exposed to you programmatically via ECMAScript 5 APIs. And all of it is getting standardized in a way that the entire DOM can be expressed in terms of JavaScript constructs, which is very convenient. In other words, the distinction between those different flavors of objects that I was alluding to before is getting less and less important. They are all blending and becoming very much first-class objects. That is it for this demo. Let's switch back to the slides. All right. One other aspect of functions that is very important is that they create their own variable scope. Like if you're used to programming in other languages, functions as well as say square brackets, curly braces for blocks of code create scope for new variables to be introduced. In JavaScript, effectively, the only mechanism is functions. There are a few others. If you happen to know them, you can come by and talk to me about that afterwards. But functions are the primary mechanism for encapsulating and preventing stuff from leaking outside. So in this example, the function defines a variable called x. And within the function, the variable is defined and has a value of 5. Outside of the function, it remains undefined. That's important, and it's commonly used in JavaScript libraries to avoid polluting the global object. If I have some intermediate variables in my code, I don't have to expose them outside. They will just remain encapsulated within my function. Functions can have access to variables in the outer scope. That's called, in JavaScript parlance, closure. So every function basically captures whatever variables are available around it. And so in this example, I can access the outer variable, and I can even change its value. So after my function is executed, the value will be goodbye. In other words, the closure, you can think of it, captures the references to the variables rather than their current values. So the important part about it is that if my function is executed later and some values of some variables have changed, I will see those changed variables. Right? It's by reference, not by value. In some cases, that's exactly what I want, but some other cases, it's undesirable. Like, for example, if I'm enumerating over a loop and I have to call some function, I want to make sure that I see every index of the loop rather than just the last one. Right? In this example here, I'm setting an interval to be called back every 100 milliseconds. And if I didn't have this wrapping function around it, I'm not sure if I have a pointer. Maybe I can do. There you go. If I didn't have this and didn't have this at the end here, anytime that callback would be called, I would see goodbye, because the value of the variable outer has been changed, and I will see the current one. If I wrap it and I pass the outer as an explicit argument, then I get to isolate my code from the changes outside. So if I want to capture the current value, I have to pass it explicitly to a function like that. OK, so let's recap what we've learned about functions. Functions are objects, first-class values. The only difference is that they inherit from function.prototype, which gives them a little more functionality out of the box. They have an implicitly passed this parameter, which gives you access to the members of the object, allows you for value sharing and functionality sharing. And then the call and apply allow you to control exactly which object you pass in. There's a new operator that you can use with constructor function and sets up the prototype inheritance chain for you. And then there are closures which allow you to introduce variable scope and control that variable scope. So we basically covered the three key concepts, the objects and prototypes and functions. One last thing that I want to throw in here is strict mode. That's new in ECMAScript 5. And in fact, that was the one piece of ECMAScript 5 that we didn't have in IE9. And we did add it in IE10 now. It is actually very useful because it allows you to catch certain typical JavaScript coding errors that are otherwise very difficult to diagnose. And the way you opt into this is by adding this string, use strict. And you might be wondering, why is it a string and not just part of JavaScript syntax? The reason it is this way is for backwards compatibility. Browsers that don't support strict mode will simply ignore it, and your code will just work. And browsers that do will give you the extra advantage of some runtime checking. One of the very common things that happens in JavaScript is if you forget to declare a variable, like in this case, I forgot to write var x, I just wrote x. This will succeed and will, in fact, create property x on the global object up above. This is typically not what you intend to do and creates pollution of the global object and can have some very unpredictable side effects. Maybe there was a property x already there, and maybe somebody expected a different value, and now you've changed it unintentionally. In ECMAScript 5, this results in an error. Another set of common problems with traditional JavaScript is that at runtime, any function that is called can walk up the call chain, the call stack, and has access to the live function objects on that stack. It could, in fact, change values of arguments of some functions up the stack. It could also inspect them, so it could see what data is there. So if maybe your incorporating some advertisements into your website and you call in to do something, they can walk up the call stack and figure out everything that is on that call stack and have access to it. That's generally bad. So in ECMAScript 5, if you use strict mode, those are usage of those two properties results in an error. And then finally, in ECMAScript, before strict mode, writing to a non-writable property silently fails. So the program just continues, but the value was never changed. It is typically a very subtle and difficult thing to diagnose. It results in bugs somewhere later in execution of your code that are difficult to pinpoint. So if you use strict mode, writing to a non-writable property results in an error right away. I might skip that demo because we're running out of time here. Let's see, we have 15 minutes? Well, I'll quickly show you real quick. I think we have enough time for that. So if you're not familiar with the IE9 and IE10 test drive website, it's a very interesting playground where you can explore new features added to the language or to the browser as a whole, as well as look at some of the performance demos. And I can close this one. It's not needed anymore. Let's see. Do we have here? Great. So this is the website itself. You will see there's a bunch of demos there, a bunch of interesting things to explore. If you grab the, where are we here? Sitemap, you can see a long list of different things that you can play with. There are both features as well as performance demos and so forth, so you can get a better sense of what's coming up and what's new in the browser. Now going back to where we were. So try strict is a demo that allows you to play around with the strict mode. And just to get a sense, I'll walk through a couple of those things. Looks like we have some neighbors who just finished. Let's look at just the first one that I showed you. So here, if I comment this out and run the code, I get 5. And the code just succeeds to run. If I check down here, what happened is that now the global object, which is the window object, .a, let me see if I can run that. I didn't do anything. How about this? Document.write this. So you'll see what actually happened is I wrote a 2 to what I intended to be a local variable a, but instead I added a property to the global object called a. The reason it shows 52 is because the two are sort of squished together. I could add a space to make it more clear. But the point is, this is not what I intended. There you go. And if I switch to use strict, this will be caught as an error, right? Unintended behavior for the most part. Rarely does anyone do it intentionally. And you can play with a bunch of other things in here that strict mode helps you to catch early. I will not walk through all of them because I want to save some time for questions. Great. Let's switch to the slides. OK. So again, to summarize everything that we've covered, JavaScript, I hope you will come away convinced that JavaScript is indeed a full-blown, full-fledged language that is simple in that it has a very small and quite elegant core. But yet it's quite flexible because a lot of other abstractions can be built on that core. And it is indeed a very powerful programming language. I would encourage you to be curious. Now with the ECMAScript 5, there's a lot of APIs, a lot of tools to try to take a peek under the hood to see how the common libraries that you might use, jQuery or what have you, actually work under the hood. And if you haven't already downloaded IE9 or IE10, I would encourage you to do so. You'll get much better performance, which is exciting to me. But also, they come with the F12 tools. So anytime you open a page, just hit F12, and that console that I showed you shows up that allow you to inspect both the DOM as well as the JavaScript that runs on a given page. And last but not least, do learn the new ECMAScript 5 features. A lot of them are very interesting and very powerful and do allow you to take a peek under the hood. And that's the summary of all that I had. If there are any questions, I'll take them in a second. There is my email address that will stay there until the end of the session. So if we don't get the question in, feel free to email me later. I'll be happy to answer directly or forward the question to the right expert on our team. And then, of course, there are some resources here that I'll just show for a moment. And make sure you submit your evals after the session. And now I'm ready for questions if there are any. And I'll try to repeat them for the mic as well. Any questions? Yes, go ahead. Because the prototype property is actually hidden, I can only get it by get prototype of. The prototype property, even though it's there, it's wired up, it's not available to me. One of the reasons is the standard does not allow you to change that property. You cannot walk up to an object and suddenly hook it up to a different prototype. Yes, the constructor function has a public prototype property, and that one you can play with. But the prototype property of an individual object is fixed and frozen. You cannot touch it. You can't even really see it explicitly. Good question. Thanks to all who are leaving. Thank you very much. If you have any questions, feel free to stay and ask them. Otherwise, feel free to go as well. Thanks very much for attending.